So is this your final answer like that?
Yep.
Okay, let's take a look here. This one, like I said, had a couple of things in it. -1 less than or equal to 2n -1. So you would add 1 to both sides. 0 less than or equal to 2n. You would divide by 2, and you still have 0 on the left. Now this is where you're going to see a difference between my answer and your answer. When you switch the variable,
I added 5 to both sides.
okay, well, you
Back and
still get the
forth.
same result. That
I switched the n around before flipping the sign.
yeah. So they probably say some things in the classroom, but if I don't know, the bigger end is with the variable, the bigger end has to be with the variable, like that.
Okay.
So that's important. Like even though 2 less than x is correct, x greater than 2 is really, really correct. Any questions on that?
No, stupid mistake.
Okay. Let's try another one here. Go ahead and give this one a try, please.
I got x is less than 3.
You said x is less than 3 like this?
Yes.
Okay. So this becomes 0 greater than 3x minus 9. Add 9 to both sides. 9 greater than 3x, divide by 3. 3 greater than x, which doesn't make any sense, so we flip it to x less than 3. All right, really good. So just a few more here. It's kind of building up to the more difficult type with the ands and the ors, but you've got to be able to do these singular ones. So give this a try, please.
I got k is greater than 2.
Say that again. K greater than what?
K is greater than 2.
Okay, let's take a look here. 7 less than, now this negative distributes to both, so it's k plus 3 plus 2. 7 less than k plus 5. And you are correct on that. Okay.
Nice.
Looking really good. So it is possible to have variables on both sides of the equation. And that's where we're going now. Just a few more of these. I mean, we've got a lot of time to fill with our lesson today. So you're going to do a lot of problems here, a lot of practice. But this one, you can see there's variables on both sides.
Yep.
So go ahead and give that
That m is less than or equal to 4.
take a look here. 26 plus m greater than or equal to -30 plus 15m. So you have a choice. Like you can move the variable. We talked about moving from the smaller to the larger a while back. The thing is you really do want the variable on the left. So this is kind of a violation of that. What did you do? Did you move the variable right or the variable left? What did you?
So I kept the variable on the left
right?
side, and I subtracted. Wait. Or sorry, I kept it on the right side and I just subtracted M, so I added 30 and subtracted M.
Okay, now I'm gonna do it the other way, just so you can see an alternative way to do this. And it is a violation of what I said earlier. It was like, hey, you shouldn't do this. Minus 14M greater than or equal to negative 56. If you do it the way I'm showing here, you then have to remember to flip the
Yeah, you have to remove.
inequality. And you've done it there. Good. All right, let's just do a couple more of these.
I got X is greater than negative 2.
Okay, like that.
Yep.
Okay, so we got negative 6 minus 36x less than 6 minus 30x. Again, there's this. I know we've talked about you move the smaller to the larger, but because the variable ends up having to be on the left, you tend to actually just always move left. But you do that after you've gotten really good at this. Wouldn't want to do it as a first thing. So minus 6x less than 12, divide by minus 6, divide by minus 6. So x is greater than negative 2. All right, very good. Okay, so the next types of problems that you're going to see are the kind of the and the or. Let's see if I can find some here. Right, so the kind of the base case here of problem is the and problems. So the and problems are always between.
Yep. And the or are always at opposite ends of like the spectrum.
Exactly. So to solve this, you subtract 3 from both sides, but there's now 3 sides. 3 less than x less than 7. When you graph this on a number line, 3, you have 7, and you have everything in between. Okay. You could also get a problem where you have division or something like that in there. So let me. All right, so you're trying to isolate x. You've got division by 5, so you multiply everything by 5, and if you're getting 20 less than x, less than 30, like that. All right. So where you potentially run into issues is when you get a two-step solving thing. You still just look at the two-step solving the way you've always done. So why don't you try this one, please?
I got 3 is less than or equal to X is less than or equal to 11.
Like that?
Yep.
Okay, and that is correct. All right, so here's one that kind of violates order of operations. This one here, you have to actually undo the division first, division by 2. And the reason is that's really in parentheses, which is why you undo division first.
Okay. Yeah, I usually do division or multiplication first. I got 6 is less than or equal to x is less than or equal to 10.
All right, now we haven't seen one like this, so I'll just have to make it up. Let's say it's 5 greater than 3 minus x greater than or equal to 2. The first thing you should notice is that the inequalities are going the wrong direction.
Yeah, they can't go that way.
Well, they can, sometimes you'll see problems like this. The other thing is that when you subtract 3, you get 2 greater than negative x.
Oh, so then the signs flip back anyways because it's negative.
They will potentially, yeah. So when you divide by -1, you get -2 less than x less than or equal to 1. And so sometimes you get a problem where you have to divide or multiply by negative, and then you have to flip the inequality. That still applies. There are also problems where you flip the inequality multiple times. And I'm not saying you would get this, but you could. So let's say you got like 5 minus x over -2 less than or equal to 8. Okay. So go ahead and solve this, and you'll see that you'll flip the inequality twice when you solve it.
Okay. Then greater than or equal to. And then check that neighbor. Negative x greater than or equal to 11. 11 is less than or equal to x is less than or equal to 11. So I got 11 is less than or equal to x is less than or equal to 11.
The same number?
Yeah.
Well, that could be. I didn't vet this one. When you multiply by negative, you get -6, flip the sign, 5 minus x, -16. So I believe you have a signer. This shouldn't have happened. When you subtract 5,
Oh, I didn't have negative. Yep, it should be 21, not 11.
right? So small change there. Okay, any thoughts on those?
No.
We're really at the mercy of the teacher to know what they're going to emphasize.
Yeah.
Let me see what else. I think you could also see stuff in kind of this multiple choice format. Did you get any multiple choice in your quiz or test?
Yeah.
Okay. Why don't we try a few of these?
2 less than a number. So x minus 2 is greater than 8. C.
Okay, so the next one is a little bit more difficult. It's kind of more of an SAT style question, but it's just the same as the last one. You have to write the inequality.
Well, $40x plus 100 is less than or equal to C again.
Which one?
C,
I still, A, B, C.
C.
Give me a word like cat, boy, dog,
Oh, C is in cat.
cat. Okay, so we got letter C. 40 miles an hour. Yes, okay. It's odd that they would do two C's in a row, although that could happen. All right, here we go. Here is a new problem to try.
Alright. And multiply by 7, 14 minus 6 is 8. X is less than 2.
All right, so one of the ways we can do this is we can actually pick a number on both sides of that. Like let's let X equals 1, and then let's let X equals 3. So that's kind of the dividing point. 4 times 1 plus 6 over 7, is that less than 2? Is 10 over 7 less than 2? What do you say?
Yep.
It sure is. Now 4 times 3 plus 6 over 7, is that less than 2? That should be false. Is 18 over 7 less than 2? The answer is no, it's not. So that's kind of a way to check these. It's not foolproof, but it pretty well. Just something to think about here. Let's look at a few more problems. All right, number 6. Here, you want to give that a try, please?
4C, 12. C is less than 3. B. B is in boy.
All right, so you got C less than 3. That does appear to be correct. Actually, this was not a very good question because they just give you that. All right. So we did solve a few of these in between inequalities. So maybe so would you go ahead and give this one a try, please?
C.
Checking here. Yeah, that is correct. A lot of C's. A lot of C's. Okay. All right. So we'll make this one free response. You'll have to solve it and graph it, and then I will put up the solution.
Okay. Okay, I got it. I got it.
All right.
Too.
So one of the things you could do here that we haven't talked about yet, but I'll show you now is you can actually divide first sometimes. I know you probably didn't do that, but it could be helpful. You do have to make sure that it actually worked, which this one does. It's 17. And then sometimes it makes it easier to solve the inequality. So just be on the lookout for some of those shortcuts here. Did you get y less than or equal to 5?
Yeah.
Okay, and then
Y is
you,
greater than or equal to 5.
yeah. This only works if the number here divides evenly into that other number. I mean, sometimes it does, sometimes it doesn't.
Yeah.
Okay. Did you get a lot of word problems in your last test or quiz?
We got a couple.
Okay. So sometimes they have you write the equation, which we've already done, and then sometimes they ask you for sort of figuring out the solution. And this one is the latter. You have to first kind of write the inequality or kind of work out some numbers to see if it works. So give this a try, please.
So it's less than, or it's C. Maximum number is C.
See, okay, let's take a look here. So did you write inequality 130 plus 3x has to be less than or equal to 190?
Mhm.
Yes, okay. And so when you solve that, you do get x is less than or equal to 20. Good.
Yeah.
All right. So now we can talk about or inequalities. And there's actually a couple of cases. So case one, the one that you see most often is what I call like the outside case. You get to the left. Well, why didn't that do that? You get to the left, you get to the right, you get kind of outside. Is that okay?
Yeah.
All right. And then, it's typically x less than a number or less than or equal to a number, or x greater than or greater than or equal to a number like that. The other case, which does happen, you will see it's like the exception. And this one we'll probably see more of towards the end, is you get left of the number. I don't know why it's doing that. And then you get to the right of the number. And it fully covers or saturates the line. Okay. And this is the case where it ends up being all real numbers. And we will see some of those at some point. But most of the time we're going to be working on case one. Okay, so let's look at a couple of problems here. Okay, so the way this works is you just treat them as they're separate. So it's really just like two problems that you've already done.
Yeah.
So go ahead and solve the one on the left, solve the one on the right, and let me know what you come up with.
So I got n is greater than or equal to 10, or n is less than or equal to 9.
Very good. Okay. So on a number line, and sometimes they don't, the number, they're not going to map in the right place, but okay, that's 9, that's 10, less than 9, greater than 10. Wow. I don't know why I'm like that. Okay, so not overly difficult here. You could though see some problems where you have some sign. You have to change the inequality direction. That could pose a small concern here. Like here's a problem. Like you to try, but again, you solve it. It's like you've done before.
Alright, a is greater than 0, or a is less than or equal to -5.
Okay. Right. And so you got to put or in your answer. You go to your number line, there's -5, there's 0, to the right, the left, that one's filled in. Make sure you remember, okay, that's filled in, that's not, things like that. Okay, so let's look at an exception now. This one is an exception. So I'm telling you that in advance. It's why? Oh, sorry, there it is. Oh, that's no good. Sorry, I'm just struggling to find one that works here. Okay, here's an exception. So you should get case 2 when you're done with this. But I'd like you to work it out and verify that for yourself here.
Okay. So I got b is greater than or equal to 0, and b is less than or equal to 0.
Like this.
Yep.
Okay, now this could be odd because you're like, well, what do I do at 0? But if there's just one point, okay, it's like, all right, to the right of it, And then to the left of it, do you see how the line is fully covered? The number line? If you're talking, I cannot hear you.
Yeah, that's what my graph looks like, sorry.
Okay, yeah, and that's why this is an exception. It's because the line is fully covered. All right, now what's more common is what you'll see in number 7 here. I should have had you do this one first, but this is also an exception. This is another type that you will see. You don't get the same number in the middle, you get two different numbers, but the graph works out the same. So give this one a try and you'll see what I mean in a moment here.
So I got n is greater than -9 or n is less than 5. Or yeah, n is less than 5. And then
So you
they
graph
like
it,
run into each other on the number line.
yeah, and they go left, and you go right, and you got it. All right, so those are the exceptions. The other types of problems we can do are kind of going back to the ands, but where I use the word and in the inequality rather than the in between. Unless you have something else that you want us to cover today. What what do you say? Do you want us to do some more of these and inequalities, something different? What else would you like to work on today?
Is there anything that gets more challenging than these?
I mean, the absolute value is what's coming next. It turns into this.
Yeah.
Okay, yeah, let's do that then. So the absolute value function of x, like let's say it's the absolute value of x is well, first it starts out with equals. So equals, let's just say 3. This is two things. It means that x equals 3 or x equals -3. So basically you set what's inside the absolute value equal to this number and then equal to negative of this number. So it gets more complicated. Like what if it's absolute value of 3x minus 4 equals 10? So you set the part inside equal to the number equal to the negative of that number. So could you solve each of these for me, please?
So then add 4, 16, 6. Then x equals -2 and x equals 14/3.
Yeah, and sometimes they don't work out nicely. It's like sometimes they're not numbers that really make sense. So the key here is being able to split it apart into the two equations. So here is here's one for you to try on your own. And you can see it comes back a lot to just solving two-step equations or multi-step equations.
Yep, and I split it, so I'd get 4 plus 5x equals 16 and 4 minus 5x equals 16.
You keep exactly what's inside absolute value, no
Oh, and
change to
then
that.
negate it.
And then you only negate the thing on the right.
And then x equals 4 and x equals 12 fifths.
Nope, try again. This is what I heard. Is that what you meant?
Yeah.
Okay, this is not correct though. There's an issue.
Oh, it'd be negative 12 fifths.
Yes. All right, let's look at another one before we move on to something more difficult. Go ahead and try solving this.
So I got a equals negative 28 fifths and a equals 6.
All right, both correct, good. Okay, so the other thing that can happen here is you can get an equation where you have to do some stuff before you do the part that we just did. And so what I mean by that is like, you have to get it so that just like in all the previous problems, it was absolute value of something equals a number. Absolute value of something equals a number. So here you got a 5, which is really positive. And this -8 is multiplying it. So you really have to get rid of all this other stuff. Like you want to get it down to absolute value minus 2n equals. To do that, you subtract 5 from both sides. -8 absolute value minus 2n equals -80. Divide by -8, divide by -8. And that gets you down to 210. So now you can split it up. But you can't split it up until it's just the absolute value.
Okay. N equals 5 and n equals -5.
The hard part isn't necessarily the absolute value now, it's just getting it to where you can do the absolute values. Here's another one like this one to try on your own here. We have to do these first before we can do the inequality stuff. So we might not get to the inequalities.
And is it a distribute because those act like parentheses, right? Should be.
You cannot distribute. In the previous problem, we undid it.
Oh, and you divide. You don't distribute. You divide it.
Yes, I mean, you're going to divide here.
Yeah, you're gonna divide by 5 here after you subtract 2. That's -5, 5n minus 5. 73. And then 13, 5n minus 5 equals 13, and 5n minus 5. 18, so that would be n equals 18. So I got m equals 18/5 and m equals -8/5.
What did you get on the right here when you divided by -5?
13.
There's your issue. It should be 15. So go ahead and retry it from here, please.
Oh, that makes sense. M equals 4, m equals -2.
That is correct. Okay, one more of this type. We'll close out with this question. You're kind of knocking them out. All right, so again, you got to undo the stuff around the absolute value, this -9, this multiplication by 6. You got to undo all that before you can proceed.
I got x equals -2 and x equals 12/5.
Yes, perfect. All right, really good. Okay, so we're gonna stop here. I mean, you kind of got it. There's more